Hi everyone, welcome in. Today I want to discuss how Kotlin provides some of its most useful library functions like map and filter using extension function. Let's start. Now let's see a quick example of how we can use map on a collection. First we'll create a list and use map function on that list and add tree to each element. Let's create a list first. Then let's apply the map function. Here map will take a lambda expression, and for that we need to provide a value parameter, let's say f, and then apply the transformation, which is a plus 3 because we want to add 3 to each element of the list. So what map function will do is it will create a new list, and what if here is doing is it will refer to each element in my list. Like if will first refer to 1, and then it will apply the transformation f plus 3, which is 4, and then place that in the new list, and then it will refer to 2, and then same for that 2, we will have 5 in the new list, and so on. Let's verify by printing. As you can see, the my list is still the same because we are not changing the original list, but the map list contains the new elements. So what is the type of this my list? Is this an internal class of Kotlin on which they are able to provide the map function? Let's print the type of my list. As you can see, this is just a standard Java library class, but somehow Kotlin is able to provide the map functionality on this Java class. So how come? Actually, Kotlin achieves this through a functionality called extension function. Now, before understanding extension function, let's solve a task using a normal function. Let's say we want to add Bazinga to a sentence. Let's create a function for that. Let's say the name of the function is @humor. That will take a string as a parameter. Then we will print it. We are printing the string itself and then adding Bazinga to it. Now let's call this from the main function. Let's give a string and run it. There, it is working. What if we want to use this @humor function as a member function of string class, just how we use the map function on the list? So what we want to do is we want to write it as str.addHumor. Probably let's change the signature a bit. So we can do exactly this in Kotlin by utilizing a concept called extension function. And the way we can write extension function is we first start with the same function declaration, and then we type the name of the class on which we want to use the extension function, which is string class here. And this is also called the reference type. And then we write the name of the function itself. As this doesn't take any parameter, we will keep it empty. And we can probably just copy paste this, but as you can see, we don't have any string parameter here. So how can we access this string object on which we are calling this extension function? So we can do that by using this keyword. So this actually refers to the object itself. That's why we get the string out of it. But also with this, you should be able to access all the public properties or function that is available on this string. And there's a special name for it. It is also called a reference object. Now let's run it. And see the same output. So how does Kotlin allow us to define these extension functions outside of the class, but use it as a member function of the class? Does Kotlin add those functions to the class definition itself? In that case, what about encapsulation? Are we able to access private methods of the class using extension function? To answer these questions, let's look at the decompiled Java code. So here we see the Kotlin bytecodes, and if we decompile it, you get the equivalent Java code. So here we have the main file from Kotlin. It gets transformed into the main kitty class in Java, and we had this main function, and you will see that we have the same main function as a static function, and this main function is calling the add humor functions. So if you see the original add humor function here, and see that add humor is just taking a string parameter, adding Bazinga, and printing it out like as expected. But what about our add humor ext function, the extension function? So you can also see here that add humor ext is also part of this main kitty class. So this is not part of the reference type, the string class. This is part of the main kitty class, and here also it is taking the string as a parameter, adding Bazinga to it and printing it out. So the signature of add humor ext is like same. So what really happened here? So what happened here is that extension function is actually just a syntactic sugar, and it gets transformed into the normal function later. So just like add humor ext will get transformed to add humor in bytecode. And in the extension function, what happens is that whatever reference object that we had, it will be added as the first parameter of the function. So like this, like the first parameter. So this is just a normal function outside, and you are accessing string like from outside, not from inside the class itself. So that's why no encapsulation will be broken, just a syntactic sugar. Now one thing you'll notice that when I wrote this extension function, I changed the function name to add humor ext. So what will happen if I kept it the same? So if I kept it the same, as you know that when it gets transformed into the bytecode, it will try to add the same function name. Like now we will have the same add humor function like twice with the same parameter type, and that way it won't be able to compile it because this is the same declaration twice, a duplicate declaration I would say. Let me just prove it to you and run it. As you can see, it's not able to compile. It says that platform declaration clash, the following declarations have the same JVM signature. So our extension function didn't have any parameter. So let's see an example with a parameter. Let's remove the normal function first. Let's say we will send this Bazinga as a parameter. Let's add the parameter in the function and use it in the print statement. Let's run it. So the output is as expected, and if we see the bytecode, you see that our suffix parameter actually is the second parameter here. So what is the first parameter? The first parameter is the reference object, the string itself. So what will happen is like whatever parameter we add, it will be added after the reference object. So now that we have knowledge of extension function, let's see the implementation of map. So if I go here, so this is part of the collection library, and as you can see, this is an extension function, no surprise there. And the reference type is iterable, and it just takes a lambda expression as a parameter. So the list actually extends the iterable. So let me just show you that. So if I go in list, you can see the list kind of extends the collection, and here collection extends iterable. So that's why list is able to use like this extension function with this iterable reference type. Now what will happen if I want to use this extension function from a different package? Let's try this out. So let's create a different package, let's say random, and there also maybe I want the main file, maybe let's just say all right. Here I don't need the extension function, but I want to call the extension function. And as you can see that from the different package, we are not able to access the extension function. So what we need to do is actually just import the extension function. And if you run it, you see that it is expected. So this basically imports this extension from the main class. Now the question is, we didn't import for map function though. So how come we are able to use map function from a different package? Because the package of the collection is like kotlin.collections. So the reason we're able to do it because Kotlin automatically imports some standard library functions to all the Kotlin files. So that's why we're able to access it. Now we might have a misunderstanding that extension functions support overriding just because we are able to invoke it like a member function. Is that true? Let's find out. Let's see a quick example of function overriding. We will create one base class, one child class, and the child class will extend the base class. Let's create the base class first. We will define a function here, a member function. And we will just print that this is the base class. Now we will create the child class, then extend the base class. We will implement the same function and say that this is child class. Now we can see some error here is because by default Kotlin, like classes and functions in Kotlin are final, so we need to open it so that others can extend it. Here you can see that we still got error because we need to, as you're overriding, we need to mention it explicitly in Kotlin. All right, now we will create a variable with base type, but we'll assign the object of child. Now if you call the member function of this variable, which function is going to get called, base or child, based on type or based on what object it is. So you see it is calling the child class. So this is the function overriding. So it gets determined in the runtime. So the runtime environment checks what object this base is, which is the child class. It doesn't check what type it is. So based on the object, it calls the relevant function, which is this one. Now let's create the extension function on these classes. Let's create for base class first. Reference type. and then the function name, we'll just use the same print statement. Then we will do the same for child. And use the same print statement. Now if we call the call.ext function, which one is going to get called? If you see that extension function is actually calling the base class, the function, like this extension function basically. Let's see the bytecode or decompiled Java code again. You'll see that the call.ext function is actually the static function of the main KT class. It's not a member function. We proved it before. And the function name is exactly same. It's just that the type is different. One is base type and one is child type. And when you call from here, this is not calling any member function. This is just calling the static function, and it is going to get determined based on what type it is. So this becomes the function overloading. So this gets determined in compile time, not in runtime. So we need to remember that the extension function, it will use function overloading and not overriding. That's all I had for extension function. I hope you enjoyed this video. See you in the next one.